Hello guys, welcome again. So we will see the first problem, which is matrix times vectors. It's an easy problem. The question is, if you read a question, right, write a Python function that takes the dot product of a matrix and a vector, return -1 if the matrix could not be dotted with the vector. So you see about the mathematics and and try to find out, but it's basic class 11th class 12th matrix multiplication. When can be the matrix when can the matrix be multiplied? So there is one situation that matrix cannot be multiplied, which says that dot. I'll try to explain this in a very simple manner. Okay, you have a matrix, let's say 2 cross 3, and you have a vector. Okay, you have a vector with a vector can be a single dimension. So I know for a fact that it ends with 1. It's only of one column, or let's say one row. And how many numbers should be there? It should be 3 cross 1, because the number of columns in this matrix should be equals to the number of rows in this matrix. That is the property of or condition in the matrix multiplication case, and this is when the matrix can be multiplied. So the question they are asking is not about matrix multiplication. They are asking about matrix times vector. Why this? Why not matrix times matrix? Matrix times matrix is used in many cases for images and so on. But matrix times vector is mostly used in text embeddings, right? For each word you will generate an embeddings in, let's say, attention, or in RNN, or let's say in word to vec. You generate a particular vector, and that vector should be multiplied with the weight matrices in order to update the weight, or in order to forward propagate. So in those cases, problems like these are most useful. So we have to find a way to efficiently implement this in Python. So that is one case. So we already know the edge case, right? If 3 is not equal to this 3, then you just return -1. So we'll try to do that. We'll have to check if this is the matrix A. If A is none and length of A of 0 is not equal to length of B, return -1. So this is the edge case. If A is none, right, A is none, or A is empty, right, you just and you have to also check is none, or the length of A of 0, which is 1 comma 2 here. And if you say B, the length is 2, these should be equal, and if it's not equal, just return -1. So we have satisfied this condition. Yeah, good, we have satisfied this condition. So next is how do you multiply matrix times vector, right? So if you see the usual matrix multiplication case, the usual thing is you multiply across row and with the column. You multiply across the row and with the column. You just sum the all the numbers with the with each of the number multiplied with the other number in the column. For example, in our problem statement, we have 1 comma 2 and 2 comma 4. We multiply 1 comma 2 with 1 comma 2, which says 1 into 1 plus 2 into 2 is 5, and 1 and 2 into 1 plus 4 into 2 is 10. So this is how it is. So for example, if we try to print this is for I in A, so what we'll be getting, I is an array or list of each elements in the matrix, each row in the matrix, and for each row we have to multiply with the column, which means in implementation wise you have I into B, right? And this should be a number. I know for a fact that when the output is 1, which means this the length, this is a column vector or a row vector. If this is this outcome is 1, so the output of the matrix is 2 comma 1, right? So when you multiply this with this one, you'll be getting a number, and you multiply again the second row with the same column, you will be again getting an single number. So those things consist of into 1. So the output is 2 comma 1. 2 comma 1. This is the output that we are talking about. So I know for a fact that as you are using vectors, the length or the column vector, it should be a column vector, which means the length of the column is actually 1. It shouldn't be greater than 1, because we are not multiplying matrices, we are multiplying matrices with a vector. So that's what I'm sure of. And how do you multiply with this? So I'll go over, let's I have used I, I'll go over to B and I'll multiply J with each element in I, which means I can use something like this, right? Range of length of B and I of J, and something like B of J, and res equal to res plus B of J. You can say something like res is equal to 0, right? Or something like this. Anything is fine. It's up to you. I'll leave that to you. And I know for a fact the output vector contains only a single list, which means you can say here C is equal to this, and C dot append of this. Okay, and let's submit the code. So I think that's probably it. But the problem with Python is Python is an interpreter, right? So we have to make the code as less as possible, which means the less number of lines and more fast it will execute. So there are functions in Python which helps us to do that. Instead of this, we can use kind of sum and something like this, and something like this, right? And is this right? Okay, probably you can reduce a little bit more, but I think it's done. Yeah, so this is the algorithm, or this is the thing. But I also said that we would be probably seeing or comparing with the other implementations, which is numpy dot. Yes, you see, let's start and Jupyter notebook. Yes. Okay. Numpy and numpy dot of 2 comma 3 is 6. So we'll try with our thing. As you can see, this A takes as a list of lets and B takes a list of int or float. So we can try something like this. Vector of 2 comma 3. Okay, 6. Okay, so yeah, I think we are done. Yes. So this is the thing, and this is used in many of the cases. And if you see even attention, right? Attention, self attention formula. There also we actually use dot product of query and key values. I think, yeah. Yes. Query and key values, where you transpose the key with that. So this matrix multiplication is used in most of the cases, but when you are talking about specifically with matrix times vectors, right? It is probably used in RNN, most probably, but it can be used in many of the cases. Even if you say neural networks, right? The weight matrices can be multiplied with the input vectors or the input values that are coming through each layer. And also the embeddings, when you convert these words to vectors, and then you have to multiply with weight matrices to get the RN in RNNs. So let's RNN computation graph. Okay, if you see this one, right? We'll try to cover the other algorithms. We'll try to implement from scratch without any help of PyTorch or TensorFlow or other things. Yes, this is what I'm talking about, the weight matrices. And after you have computed, you will be getting some output, and the output is used for the next recurrence unit, which is also computed by using weight matrices. So when you have these embeddings or the words in x1, x2, x3, right? These embeddings are multiplied with the weight matrices in such a manner to get the into the next layers or the next recurrent units. So this is very useful in those cases. So yes, matrix, this is matrix dot vector. In the next video we will see how do you transpose a matrix and what are the ways of efficiently transposing a matrix, and then transformation and so on. Thank you.